So, we went out there through the window, and you guys went down here, and I was up here, and I threw a bowling ball out. I also threw a bowling ball, then I threw a bottle, and then I threw a marble. And none of those have a lot of air resistance. So regardless of their weights, they should have hit the ground about the same time. If you got a different time for all of them that was far off, that was my fault the way I threw them. Does that make sense? The falling would have been the same. What did you get? What did you get, Emma Johnson? What did you get for your bowling ball time? How long did it take the bowling ball to hit the ground from all the way up here?
I got 1.15.
That's not far off. What about you, Isabel? 0.96. So y'all are almost exactly 1 second. What about Maddie? What about you? All right, so everybody got almost exactly 1 second. What about this bottle? What did you get, Terena?
1.01.
So again, same time. So the bowling ball and the bottle both hit at about 1 second. What about the marble? What did you get from the marble?
26.
You got a little bit faster. What about you, Caleb?
1.07.
1.07. What about you? So basically, almost perfectly, no matter what I threw out that window, hit the ground at the same time. We all agree on that? Okay, so we're just going to talk about the bowling ball because it's the most fun, right? Did y'all feel the ground move when the bowling ball hit? You did? If you're close, you can feel it. So we chunked this out the window. And we know, because we're on the planet Earth, that the acceleration of this bowling ball is 9.8 meters per second per second. We call that acceleration gravity, right? Right now, you're trying to accelerate like that into your desk. What's keeping you from doing that? What's keeping you from speeding up to the floor right now? The chair. That's exactly right. The chair is pushing on you and keeping you from doing that. If someone pulled the chair out from under you, wouldn't you start accelerating towards the ground at 9.8 meters per second? Right? Okay. So, we dropped the bowling ball out the window. And what'd you get for a time, Aubrey, for the bowling ball? 1.05. 1.2, that's a little long, you're a little slow. Thomas?
For the what?
Bowling ball.
Oh, 0.97.
0.97. Terena?
0.96.
0.96. What you got? 1.05. What you got? Emmer?
1.01.
1.01. So I'm going to make it easy. Everybody write this down. We're going to use 1 second. And it's about right. This window is about 1 second high. It took the bowling ball 1 second to hit the ground. So we're going to do some math. And you tell me, how fast was the bowling ball going when it hit the ground? It's going 0 right here, correct? And it's speeding up until right before it hits the ground. What was it? Maximum speed. It's almost too easy, isn't it? Here is the formula. I'm going to erase this out from under our faces. I'm going to just get all the stuff that doesn't matter. You guys timed it with the stopwatch. Here is the formula. Acceleration is equal to change in velocity over change in time. All right? We know that the change in time is how long it took the bowling ball to hit the ground. Ladies and gentlemen, the change in time in this situation was 1 second. So erase delta t and write 1 second there. Okay? Everybody with me on that? Correct? Elias, what is the other number that we know? We know the acceleration of the bowling ball because we're on the planet Earth. What is the acceleration of something that falls? 9.8 meters per second per second. So we're going to write this down. 9.8 meters per second per second. All right? And now we're going to solve for the change in velocity. At the top, the velocity of the bowling ball is equal to 0. At the bottom, that's our new velocity. This is what we're looking for, the maximum velocity that we crash into the ground with. Okay? How do we solve for this? We have a number on the bottom and a number on this side. We cross multiply. When you cross multiply, what do you do with the number on the bottom and the number on the top on the other side? You multiply it. So everybody, you would say this, 9.8 meters per second times 1 second. So here's how that works. Obviously we know the number is 9.8. Let me show you how the seconds disappear to give us the velocity. You say 9.8 meters per second times 1 second. And then in reality, these seconds end up canceling each other out. And you just end up with 9.8 meters per second is the velocity. Does that make sense? So that's it. And now we would say, hey, if this bowling ball fell for 2 seconds, it would be going 9.8 times 2. If the bowling ball fell for 3 seconds, like off the Empire State Building, it would be going 9.8 times 3. Everybody agree with that? We're going faster and faster and faster. So that's all there is to calculating the acceleration of an object that's falling. You just time how long it falls and multiply it times 9.8. Does that make sense? All right. We're going to do that. So now that we know that information, and we know that the acceleration on Earth is 9.8 meters per second every second, I can drop this bottle, and you can tell me how fast it's going when it hits the ground. Does that make sense? I'm going to go 1, 2, 3. Actually, I need to do it faster because it's such a short. 1, 2, 3, go. That's what I'm going to do. Everybody ready? Can everybody see the ground?
Yeah.
All right, ready? 1, 2. All right, here we go. Everybody ready? 1, 2, 3, go. That's it. Now, that's hard to do, isn't it? You want to try it again?
Yeah.
All right, here we go. We'll try it again. We'll get an average, the best average. Same height. Everybody ready? 1, 2, 3, go. All right.
Yeah.
It's hard to do. All right. So we all talked in the classroom, and we all averaged our times. It's probably a little bit high. We're going to go with this. 0.4 seconds. We think that's how long it took that bottle to hit the ground from me standing on top of the desk. So we're going to use our formula. Acceleration equals change in velocity over change in time. And without any more help from me, I want you to tell me how fast was this bottle going when it hit the ground. Go. So, doing the math, we would say to ourselves, the acceleration on Earth is gravity. So this thing is accelerating down at 9.8 meters per second per second. The amount of time it took it to hit the ground is 0.4 seconds. So we're going to go here, we're going to say, boom, click, 0.4 seconds. So now we can get the change in velocity. The change in velocity is just the maximum velocity, because how fast is it going before I let go of it? 0. So 0.4 is on the bottom, so 0.4 times 9.8. So you just say 0.4 times 9.8. And what does that get you, everybody? What? 3.9 meters per second. 3.9 meters per second. Y'all look for your homework tonight.